Draw a tape diagram to represent each expression. The unknown value. 2 more than the unknown value. So we'll add 2 to the end of it. Twice an unknown value. That would be 2 of them. 1/2 of an unknown value. Match each tape diagram with the system of equations it represents. So here I have x plus y plus 3 is 10, and the other one is 2x equals y. That is C. This one is x plus y is 10, and 2x plus 3 is equal to y. X plus y is 10, 2x plus 3 is equal to y. That is system A. X plus y is 10. X plus 3 is y. That is system B. This one has 2x plus y is 10. And y plus 3 is equal to x. So that is system D. This problem asks us to solve using tape diagrams. However, we are going to solve them using either the substitution method or the elimination method, which I haven't taught you yet, but if we get to a problem where elimination would be the preferred method, I'll show you how to do that at that point. So here we can see it's solved for x, so I'm going to replace the x in the other equation with what x is equal to. We'll distribute. 2 times y is 2y, 2 times 3 is 6. Then combine like terms, 2y and y make 3y. Then we need to subtract 6 from both sides. 10 minus 6 is 4. Divide by 3 on both sides and we get y equals 4/3. Remember, we write our answer in the form of coordinates, so the y value should be in the y position. And now we need to plug the y value back into one of these equations. So I have x equals 4/3 plus 3. Well, if I was going to make that out of 3, it's currently out of 1. So I need to multiply the top and bottom by 3 to turn it into the same common denominator. 3 times 3 is 9. 1 times 3 is 3. 4/3 plus 9/3 makes 13/3. Then let's check it in the other equation. 2 times 13/3 plus 4/3 equals 10. Well, 2 times 13 is 26 plus 4/3. 26 plus 4 is 30. And 30 divided by 3 is 10. So we have a correct solution. This one is also solved for a variable, so we can replace the y value in the other problem with 5x plus 3. We'll combine our like terms. Subtract 3 from both sides. Then divide by 6. which comes out to 12. And that is the x coordinate. Now we'll substitute it into the problem and solve it for the other variable. Y is equal to, let's see, 75 minus 12 is 63. And we can also check that it is correct. The y value is 63. The x value is 12. 5 times 12 is 60. And 60 plus 3 is 63. So this is correct. Problem 4 asks us to solve it using tape diagrams as well. However, this one is a problem that would be set up for elimination. So I'm going to show you how to do elimination instead using these same sets of equations. So we're going to kind of ignore parts A and B, and we're going to just solve these equations using the elimination method and then take some notes on the process for the elimination method. In the elimination method, we try and make one term the opposite of a term from another problem. So here I see 3x, and this one is x. The opposite of 3x would be negative 3x. So I'm going to multiply this whole equation by negative 3. Then we'll distribute negative 3 times x is negative 3x. Negative 3 times 3y is negative 9y. And negative 3 times 10 is negative 30. So now I'm going to use that red equation and this equation. And I'm going to add them as if I was adding multi-digit numbers together. So I have negative 30 plus 28 is negative 2. Negative 9y plus 8y is negative 1y. And negative 3x and 3x make 0. So that's why it's called the elimination method, because we've eliminated a variable. Now to finish solving it, I divide by negative 1 on both sides, and I get y equals 2. Now we still need to replace that 2 into one of these original equations. So I have x plus 3 times 2 equals 10. 3 times 2 is 6. Subtract 6 from both sides, and we get x equals 4. Now let's check it in the equation to make sure we have a correct solution. 3, the x is replaced with 4, plus 8, y is replaced with 2, equals 28. Let's see, 3 times 4 is 12, 8 times 2 is 16, and 12 plus 16 does make 28, so we know we have a correct solution. I'm going to recommend that you get out a piece of paper or your composition book where you take notes. So we're going to start by ensuring that both equations are written in standard form, where the x and y variables are both on the left side or both together. Then we're going to choose a variable to eliminate by making the coefficients opposites. So in our problem, we made it 3 and negative 3. We had to multiply one equation by a number to make it the opposite of the other, but in some cases you may need to multiply both. Then you added the two equations together, and we solved that new equation, the result of the adding together, for one variable. We have to plug that value back in to solve it for the other variable. And then finally, we wrote our answer as an ordered pair or a set of coordinates in the form x and then y.